Hello friends, welcome to Bindu Dhadwal chemistry lessons. Our topic for today is P block elements, an introduction. There are 118 elements which have been arranged in a table known as periodic table. We divide the elements of the periodic table into 4 parts depending upon the orbital in which the last electron enters. If it enters the S subshell, then the elements belong to S block. Similarly, we have P block elements, D block elements and F block elements, the electrons. The S and P block elements are collectively called the representative elements. In this chapter, we will be talking about P block elements. The group number 13 to 18 belong to the P block elements because the last electron enters the P subshell. The elements of group 13, boron, aluminium, gallium, indium and thallium, we have already studied group 13 and 14 in class 11. Similarly, 14 group is carbon, silicon, germanium, tin and lead. Today we will be covering group 15 elements: nitrogen, phosphorus, arsenic, antimony and bismuth. Now, so nitrogen family belongs to group 15. Their general electronic configuration is ns2 np3, 1 electron in each of the p orbitals. These members are also called nicogens based on the word nicomegs, which means suffocation. So you can see that in presence of these gases, suffocation occurs. So the name is given. Now the various elements of this family are nitrogen, phosphorus, arsenic, antimony and bismuth. Electronic configuration of nitrogen is 1s2, 2s2, 2p3. So we can also write it in this manner: configuration of noble gas helium into, and last shell contains 2s2 and 2p3 electrons. Similarly, phosphorus, configuration of neon plus 3s2, 3p3, arsenic, argon 3d10, 4s2, 4p3. Antimony, configuration of krypton, then 4d10, 5s2 and 5p3. And bismuth, xenon, 4f14, 5d10, 6s2 and 6p3. So the last shell always has ns2 and np3 electrons. Occurrence of these elements. So nitrogen, although it forms 78% by volume of air, still its abundance is low. It is the 33rd ranked element in Earth. The ores of nitrogen are sodium nitrate, called chili saltpeter, potassium nitrate, Indian saltpeter, and silver nitrate, also known as lunar caustic. In biology, also forms a part of proteins, amino acids and nucleic acids. Phosphorus is the 11th most abundant element. It belongs to apatites, having the formula 3 calcium phosphate, Ca3PO4 twice, and CaX2, where X can be fluorine, chlorine or hydroxide. If it's fluorine, the ore will be called fluorapatite. If it's chlorine, chloropatite. If it's hydroxide, it is called hydroxyapatite. Phosphorus is also a constituent of bones, living cells, nucleic acids, ATP, ADP, phosphoproteins. The other elements, arsenic, antimony and bismuth, are found in traces in the form of their sulfide ores. For example, arsenopyrite FeASS, stibnite Sp2S3 and bismuth glans Bi2S3. Now, atomic radius of group 15 elements is less than that of group 14 elements. It has smaller size than group 14 element due to more nuclear charge. Nitrogen has radius 70 picometer, phosphorus 110 picometer, arsenic 121, antimony 141 and bismuth 148. So down the group, the size goes on increasing due to increase in the number of shells and increase in screening effect. You see that the difference in atomic radius between nitrogen and phosphorus is large. This is because the intervening electrons belong to s orbitals. The screening effect of s orbital electrons is more, because of which the hold of nucleus decreases on the outermost shell electron and the size is greater. As we move from arsenic to bismuth, arsenic, antimony, bismuth, though the size increases, but the difference in the atomic radius is small. This is because of the presence of completely filled d and or f orbitals in the heavier members. The d and f orbitals show poor screening effect, poor shielding effect, because of which the increase in size is comparatively less. What is shielding effect? The inner electrons, they protect the outer valence electrons from the hold of the nucleus. Now, as S and P have good shielding effect, the difference in size is greater. D and F have poor shielding effect, so difference in size is small. Next property is ionization enthalpy. Ionization enthalpy, the energy required to remove most loosely bound electron from isolated gaseous atom of the element in its ground state, is called ionization enthalpy. You give energy to the element M, which is in the gaseous state, it loses its electron and comes in the ionic state, M positive, again in the gaseous state. First ionization enthalpy decreases as we go down the group. Also, the first ionization enthalpy of nitrogen family is greater than that of carbon family, group 14. This is because the elements of group 15 have greater nuclear charge, small size and stable configuration. NS2, NP3. NP3 is exactly half filled, and you know half filled configurations are more stable. On going down the group, the ionization enthalpy decreases because of increase in atomic size. Every time there is an additional shell that's added to the atom, and increase in screening effect. These two effects overweigh the effect of increased nuclear charge, because of which the size could have reduced. The first ionization enthalpy, the energy needed to remove first electron, is less than the second ionization enthalpy, and which is less than the third ionization enthalpy.